start soon? Okay. So for this second session, we have 3 speakers, and this session will be chaired by Dr. Philip Smith, and he's from NSRC. He's a senior network engineer and training coordinator, assisting with network operation group coordination and providing network design assistance and training around the Asia Pacific, South and Southeast Asia, and the Middle East and Africa as well. Dr. Phillips, please take the stage.
Good morning, everyone. I'm only the session chair. You don't need to applaud. It's the speakers who need the applause. So I would like us to make a start to the session here. As the introduction was saying, we've got 3 presentations. So this is probably the first of the technical sessions for this peering forum. But before we start with the speakers, I would like Nan to come on stage. We also have peering personals right at the end of the session. And if you haven't heard what those are about, or don't know what those are about, I'd like Nan to come and just explain for a couple of minutes what the peering personals are, and get yourselves ready for that after we've heard from our speakers. So Nan, can you pop up and...
So, good morning, everyone. I am Nan. So, I would like to introduce you a little bit about the peering personal. Next, please. So, peering personal is an open session for everyone to introduce yourself or your organization. What do you do, or what the location of your peering. That will encourage everyone to make a peering on the peering forum. Next slide, please. So we will have 2 peering personnel. The first one will be at the end of this session 2, and another one will be at the end of the session 3. So you can send your update slide for the peering personnel to the event at BKNIX.co.th. So we will have another session on the afternoon too. So this is just a template. You can download it from the peering website. Okay. Then we will start at the end of the session. Okay. Thank you.
Okay, that's nice and simple. So I think those of you who have been at the BKNIX peering forum before know what has to be done. So as Nan said, the simplest thing to do is take that one simple slide, use it as a template, fill in your organizational details, email it to events@bknix.co.th, I think it was. And then you get your 1 minute up here on the stage to explain what your organization does, where you interconnect, and so forth. So please make use of that opportunity, not only if you're peering here in Thailand, but anywhere in the world, really. So maybe some of the internationals can drop in their peering personal to serve as an example for those of you who might be a bit shy. But if you're running any network and appearing anywhere at all, take the opportunity to just really promote what your organization does and where it interconnects around the region. Okay, so I've dithered enough. So we can invite our first presenter on stage. Tashi Phuntsho from APNIC is going to be talking about how to secure the routing system. Tashi, the stage is yours.
Thank you, Doc. I still keep calling, I have this habit of calling Dr. Philip, Dr. Philip. Many people call him Philip. Anyways, thank you so much. Securing internet routing. Lately, there has been quite the craze in the community, as if it wasn't important until now. But anyways, why should we even worry about securing the internet routing? I did the same talk at MMIX, and somebody told me that your talk seems a bit more like a researcher's talk. Why don't you think of it, make it like an engineer's or a manager, make it interesting for them? So if you were a manager running a network, why would securing the internet routing system be of interest to you? Well, for sure, nobody wants to be in the news for the wrong reasons, right? None. Can I get some help? It's not moving. Okay, it is moving now. So nobody wants to be in the news for the wrong reasons, right? This was last year, end of year 2018, where and even that happened somewhere in Africa ends up having a major impact. Someone leaked out Google's routes in Africa, and then it ended up being carried over by transit providers in Russia and then gets black-holed in China. So the impact, a mistake, small mistake somewhere else has a global impact. Next one, please. This one was very interesting, where using BGP to hijack, this is not working, thank you. While they figure it out. This one was an interesting one where BGP was, since it's the easiest one to do, so they ended up doing a hijack of the whole of Amazon's DNS prefixes. And then using that, once I control your DNS as during the keynote use, so that if I control your DNS, I pretty much control what you see. So I hijack your DNS prefix first. Every query that comes to etherwallet.com, I give you answers and I point you to places that I want you to go to. And that's how within 2 hours, they ended up emptying a cryptocurrency wallet worth $17 million. So 2 hours of BGP hijack, early retirement, $17 million for 2 hours is a good value. Next, no? A bit, yep. The next one in the news, even the likes of Google seem to make mistakes. They leaked out entities' more specific routes off to their peers. Verizon in this case, the leak happened again somewhere in the US, and it impacts internet in Japan. Here is an example that I took from Din's blog. The Japan to Japan traffic during the leak, it actually gets routed via the states, comes back. So it's something that's 10 or 15 milliseconds, all of a sudden is 300 milliseconds. And the problem is if you have delay sensitive applications, they don't work anymore. And if you look at even Europe to Europe during the leak entities prefixes, they all again go to the States, back to Europe. Next one. And of course, the most famous one is Pakistan Telecom. Pakistan Telecom to the world that they are YouTube, and everyone believing they are indeed YouTube, and we send all our YouTube traffic to them, and YouTube is not available for close to 2 hours. So why should we even worry? That was as a manager. As a manager, you don't want your company to be in the news for all these wrong reasons. But as an engineer, me as an engineer, I don't want to be woken up at night to say that, hey, your routes are being hijacked by someone. Thank you. And this is a case. One of my friends was last time attending ICANN in Kobe, and then while he was there, his prefixes were being hijacked. I'm not going to name names, but he's from South Asia, and then so we were trying to help him figure out why it was happening. So all these things keep happening, and it's big names involved who have technically competent, highly paid engineers working for them. So why does it keep happening, right? First thing that comes to mind is the fact that no one is in charge of the internet. It's a decentralized, distributed environment, which means there is no reference model that I can look up to. If I look at a BGP table here, how do I compare that against? Is that a correct? I need to be able to compare it against a reference table. We don't have that because the internet is decentralized. And the worst of all, the way internet routing works is I tell you what I know, You tell me what you know. So it is based on rumor. How do you know that what I tell you is correct? How do I know that what you tell me is correct? So I pass my network information to you. You pass it along to your neighbor. You pass it along to your neighbor. It's almost like playing this game of me telling a word starting from Professor Kanchana in the front, and if I ask Matt here to take that route, the word would be really different by the time it reaches to me, and that's how internet routing works. So probably it's what causes this. So we have to assume that whoever gives us that information, that rumor, is telling us the truth. So it's an assumed truth. And routing is variable. When you look at a routing table, it depends where you look at it from. If you're sitting here, you see it very differently. If I'm sitting in the Himalayas in Bhutan, I see it very differently. You look at it from a Pacific node, you see it very differently. So it's a problem because I can't compare that against anything. If I look at a table that I see in Bhutan, it looks very much different to how people see the routing table elsewhere. So there is no way I can make a comparison. So I don't know whether this table that I see or the view I see is right or wrong. Right? And of course, the most unique of all, routing works in reverse. Before our traffic flows, we exchange network information. It's like you inviting me to your place for dinner, but for me to come to your place for dinner, first you need to tell me your address. So routing works that way. I first need to tell you my network information, you tell me your network information, and then only our traffic exchange can take place. That means I could take Professor Kanchana's network information, tell it to Matt, and all of a sudden traffic that was supposed to go from Matt to Professor Kanchana comes through me. So the fact that it is designed that way means it is that easy to hijack someone's route, right? Because it works in reverse. And of course, as always, anything on the internet, a bad traffic does not identify itself as bad. Right? A bad BGP update does not say I am bad. So there is no evil bit, as they say. So how do we do it? It's very, very difficult to identify bad. So as everything security currently on the internet, the idea then becomes, how can we identify what's good then if we can't identify what's bad, right? So everyone tries to identify what's good. And that's the basis of most of the cryptographic tools that we have. The idea is to at least tag it as good so that anything outside that, we assume it to be bad. And why should we bother? It's just so easy. Hijacking, a BGP hijack is not difficult at all. Right? All these incidents that we keep seeing. So currently, what do we do when we want to peer with someone? So these are the current tools that we use. I receive a request from someone to either peer with me or either to provide transit service to them. So we do what's called the legitimacy of address check, right? LOA, the legitimacy of address check. I verify that, okay, you want to peer with me. Based on your identity, I look up what resources you have, and I look them up manually in most cases, and a little bit of automation in some cases, right? And based on what I see, then I create filters, inbound and outbound filters, and that's what we do currently. And what are the tools that we have at the moment? First one, if somebody wants to peer with me, go look up the WHOIS database, right? To see whether they are who they are and whether the resources that they want to send me are theirs. The second one is quite weird, a letter of authority. I don't know, it doesn't happen in our part of the world. In Bhutan, you know, legal system is not so strong, but I guess this is a hangover carried from the West, where legal liability is a big issue. It's not security, right? Letter of authority is not security. It's absolving yourself from legal liability, right? And the third one is Internet Routing Registry, so RPSL. So what do we do? Somebody wants to peer, I look up the database, and I make sure that, okay, so you are indeed the holder of this resource, right? In this example that I'm using, IDET-num tells me that, okay, this address was indeed delegated or allocated to you. And then I look up the identity of the organization, right? And this is the letter of authority, a piece of paper that says, okay, it is not security. This. In case things go wrong, you're not in problem, and you absolve yourself of any issues when things do go wrong. most of us would be relying mostly on internet routing registries, right? So whenever somebody sends me a request to peer, I would look up entries in the routing registries. If there are entries, fine. If there are no entries, I would ask them to go ahead and update or create entries in the routing registries, right? So basically, the kind of entries that we're looking for are route or route 6 objects, right, which shows a prefix and who is allowed to originate that, right? And you will also find inter-AS routing policies in the Internet Routing Registry databases, right? So I've given here an example. Of course, by default, it all points to RADB. So looking up this prefix, I get, okay, there is the route, and there is the origin, the AS that is supposed to originate it, right? So a routing registry has entries which shows which AS is supposed to originate a particular route. And most of us actually, most of the networks rely on internet routing registries to automate their filters, right? I've given here 3 examples. The idea being, if the entry exists in an IRR or database, you will accept those. What does not exist, you will filter them out. So we need to be really careful, and that's why many people insist that you create entries in the routing registry, right? Because you will accept whatever is in that database, and anything that's outside of that database, I filter it out, I drop them. So here is an example. I'm using an RPSL tool called BGPQ3 here in this example. The first one is how do I generate a prefix list, a V4 and a V6 prefix list, right? I don't know if you can see it from back. I can see it clearly here, but a Cisco syntax prefix list, V4 and V6, right? Second one, a bird syntax. In case you have bird routing, you use bird operating system. Or if you are peering with a peer who has lots of downstream customers with lots of autonomous systems behind them, then we generally use proxy aggregation objects like AS sets, right? So that's a AS set. So generally, we end up using RPSL tools, point them to our IRR database, and then we auto-generate filters. And probably that's why most of things are broken, because the problem with IRR database is whenever I auto-generate a filter, my filter is only as good as the accuracy or correctness of the entries in that database, right? There are just so many IRRs, right? Problem with any IRR, no authority model. That means what? How do I know that the person who actually, the entity who owns that prefix actually created that entry? Anybody can create that entry. Just in Myanmar last week, YTP, I was helping them creating their ROAs, and turns out 2 of their /24s already have route objects, historical route objects in RADB, right? That's the problem, no authority model. So I don't know what's current, I don't know what's historical, but when I generate my filters, it will all depend on those entries sitting there. And there are just too many internet routing registries. At last count, about 25 or 26 of them, right? So whom do I trust? I look up one routing registry, I see an entry, I look up another routing registry, I don't see the entry. So whom do I filter out, what do I accept? But you can't trust it. And the worst of all, incomplete data, right? Especially for small or medium ISPs, there is no incentive to create entries in the routing registry. So the fact that if you want to peer with me and if you are filtering based on IRR entries, the fact that I did not create an entry in the routing registry, does it mean that the route does not exist? The route exists, right? I own that prefix, for example, but it's just that I'm too lazy to create an entry, but you will filter me out now, right? And the last one is quite interesting because I used to work more for a stub ISP. That means we need to peer with a lot of upstreams. IRR does not help me filter upstreams. Right? With upstreams, I still need to rely on my manual filtering where I don't accept bogans, don't accept special addresses, and then allow the rest of the world. So that's the problem with using routing registries. Right? So back to the question of, the problem with most of the route hijacks is, how do I know that a particular network is allowed to originate that particular prefix? So it comes back to the fundamental question of, how can we identify what is good since we can't identify what's bad, right? PKI is a very, very mature system. People have been using it. So the idea is, can we use digital signatures to identify? If I am owner of a prefix, or if I have been delegated a particular prefix, can I use digital signatures to say, okay, I authorize this network to originate this prefix on my behalf, and I sign that authority, right? The fact that I sign that, now using the PKI chain of trust, people can validate that signature up the chain of trust, right? So how do we build trust? When it comes to numbers, it's pretty straightforward. There are 5 RIRs, only 5 RIRs, and then there are NIRs, of course. So the delegation hierarchy is pretty straightforward. INR to the regional internet registries, down to national internet registries, or directly to the ISPs. So we could build a chain of trust using this delegation model itself, right? So the idea being, all the RIRs have a self-signed root certificate, right? So they are the certificate authority, CA or the trust anchor. And then whenever they delegate, RIRs delegate resources down to end holders, they also issue a resource certificate. Now that resource certificate is signed by the RIR's private key, that's the digital signature. And using that, anyone who has received resources from their registries can now use that certificate to sign any authority. Maybe I want to authorize this AS to originate my prefix, right? So that's how resource certificates work, right? So in terms of routing, what does that mean, right? Now what we are saying is, whenever someone delegates a resource, they will also give a resource certificate which binds that particular resource to that entity's public key. That's how cryptography works, right? And then now using that, I can sign off any authority. But in terms of routing, what that means is, to simplify things, in terms of routing, if I'm a prefix holder, using that resource certificate, I can authorize any AS number, any network or autonomous system to originate a route on my behalf, right? So for example, I am the owner of this prefix, a /19 prefix, and my route origin authority digitally would look like this. That prefix, a /19, maybe I want to deaggregate it down up to a /24, so that's why the max length is /24, and I'm saying I want the AS number 17821 to originate this route on my behalf. So this is what route origin authorization is, right? So me as the owner of that resource, I authorize. And I sign this authority using my resource certificate. And putting it all together is what we have now, filtering. So now that we have a way of digitally signing authorities, that means if everybody creates ROAs or route origin authorizations, at the moment, we filter based on what? We filter mostly based on IRR objects. Now, all of a sudden, we can also filter based on route origin authorizations, right? So all the RIRs will publish their ROAs to a global repository. And then what you need is a RPKI validator, which is also called a relying party, whose job is to collect all these ROAs that exist out there in the global repository and maintain an up-to-date cache of that in a validator. So that part is the relying party and the RPKI infrastructure. And then, I don't know, right? Yeah, you're right, is my infrastructure. And I don't need to do it on every router in my network. I just need to do it on my edge routers, right? My border routers, my transit routers, my peering routers. So on those, I just configure a RTR session that now talks to that validator. That validator has a cache of all the existing route origin authorizations. And every time somebody sends me a BGP update now, every time somebody sends, in this case, 240.66400::/48, I receive that update. Before I decide what to do with that update, I now check and look at my validated ROA cache and say, is there a valid ROA or not? If the prefix matches, and the prefix length matches, and the origin AS match, I say it's valid. Then I use it for my best path selection process. If either the origin AS is wrong, or if either the prefix length is wrong, then I say it's invalid. And I decide whether I should drop it or not. But at the moment, most of the internet is not found, meaning I don't have a ROA to compare it against. That means people haven't created ROAs yet, route origin authorizations. That's why you will find that at the moment when you do, if you try to filter based on route origin authorizations, you will see that close to 70 to 80% is not found because you don't have a ROA in the system to compare it against. Right? So we generally tag those routes as not found. Right? So all that idea is good when it comes to origin validation. That means now I have a mechanism using digital certificates and digital signatures to make sure that nobody can originate my prefix without my permission. So we have managed to prevent hijacks, misoriginations or route hijacks, right? But is that good enough? Because route origin, if you saw a ROA only says one thing, that this prefix and this max length is allowed to be originated by this particular AS number. It is not difficult to sit in the middle and spoof a AS number. I could be sitting in the middle and I could be using the correct AS number, and all of a sudden your route origin validation filters will say it's valid, even though I am trying to spoof someone's AS, because it only checks the origin AS against the prefix and the prefix length, right? So which means all of a sudden, to complete the picture, we need what's also called AS path validation. I need to be able to validate every path that I have sent that route to. Example, if I have this path and this two paths, if I announce that route to this path, I need to sign that path also. So that's called AS path validation. Right? The concept is pretty simple. AS1 to AS2, whenever I send a BGP update, I sign that path, right? When the router in AS2 announces that off to its neighbors, it signs on top of the signature that I already sent. So you end up creating this chain of signatures. Right? So conceptually, AS path validation is doable and it's straightforward. And whoever receives that particular route, they will do two things. First, they will check that a ROA exists for that, a route origin authorization, that there is a prefix and there is an origin AS, checks if it's valid, all good. And the second part is the heavy duty part. The second part is then what it will do is it has received a prefix with that many chains of signatures of every AS path it has come through, so it needs to now validate those up the chain of trust again. Very heavy duty crypto work on the router all of a sudden, right? Route origin validation makes sense because the cryptography is handled by the validator. The cryptography does not come to my router. That means I can use inexpensive routers. But with AS path validation, all of a sudden crypto functions come to my router, which means it's expensive now. Only vendors are happy, right? Because they can sell me now beefy boxes. So that's the problem with AS path validation. Probably that's why it's not taking off, because it's just too expensive for us to do. And in a normal BGP without cryptography, whenever I send an update, I can actually group prefixes with similar attributes. Yes, regular BGP. So I can multiplex a lot of prefixes with similar attributes, and within one update, I am able to advertise that many prefixes. But with AS path validation, you can't do that anymore. It has to be per prefix. That means you end up sending a lot of BGP updates. Me as a receiver, I end up processing a lot of BGP updates because you have to cryptographically sign them per prefix. I can't group prefixes anymore. So more CPU, more memory, right? And the idea is so good, but there is no mechanism that says, how do we distribute all these certificates that we need? Because now we need certificates for every AS path. So no one knows. There is no mechanism out there which says, okay, let's use this way of distributing certificates to every router on the internet, right? With route origin validation, you can do phased implementation. Some people are already doing it. Some networks are still not doing it. We have lots of 80 to 90% of the internet is not found. Yet it doesn't break things, it works. But with AS path validation, not so sure if partial adoption works. Maybe this path is validated, that path is validated. All of a sudden, if the third hop is not validated, what do I do? Right? So it may not be able to cope with partial adoption. And the last one, given that it involves so much more overhead, more CPU, more memory, can it do more than just prevent man-in-the-middle attacks? Right? Can it prevent route leaks? Right? So, we have route origin authorization, we have internet routing registries, and then all of a sudden there's the idea of BGP path validation also. But as we saw, path validation isn't happening because of so many reasons, right? But what can we do? The least we can do is maintain basic BGP hygiene, right? Anyone who runs a network, irrespective whether RPKI exists or whether these features, basic filtering should be a part of our daily job, right? So this is what we're saying. First thing, RFC 8212. Problem with BGP is permissive by default. The moment I bring up a neighbor in BGP, just enable the neighbor session, and without me doing anything, BGP starts announcing everything to that neighbor, right? So if I am just enabling two neighbors, I can have inter-AS or inter-AS leaks start happening without me telling it to do anything. All I did is just brought up a BGP session, right? So RFC 8212 tries to prevent that. But the sad part is there are no known implementations except for few operating systems, right? About 3 or 4 operating systems. Bird does it since version 2, XR does it, SROS does it, and the rest, there are no known implementations of this to prevent route leaks. But you can still do something similar, right? Normally, best practice configuration for us where we were grilled in our head is shut down the BGP session first while you're configuring things. Make sure you have explicit import and export policies and then only enable your BGP session, right? So that is as good as RFC 8212, right? So that prevents your route leaks, right? And of course, the third one, all those big news that we saw where Google prefixes, Google leaks entities prefixes, or Google's prefix gets blackholed because it got leaked somewhere in Africa, all those would have been preventable if there were good prefix filters, right? If main one had good outbound prefix filter, right? Or if Trans Telecom had good inbound prefix filters, none of those leaks would have happened. So the least we can do is have good prefix filters and have a limit to how many prefixes you accept from your neighbor. Don't just blindly accept, because during the entity OCN leak in Japan, there were about 120,000 extra prefixes. So if I had a prefix, max prefix limit, that leak shouldn't have happened. The moment it crosses that threshold, I shut down the BGP session or at least alert, right? AS path filters. AS path limit. AS path limit is really important. Our chief scientist, Jeff Houston's research has shown that the internet is what, about 6 AS hops deep? 6 AS hops deep. Whereas if you look at the routing table, you'll find some prefixes which come with 20, 30, 50 AS path prepends, right? It takes a lot of memory. So limit those things. You can still continue to filter things using IRR objects, but be very careful because that database is not an authoritative database. So instead, what I suggest to people is, if you're within the APNIC region, use the source option as APNIC. Because whatever objects, for people to create objects in the regional internet registry database, you need the right credentials, be it RIPE, be it APNIC, be it ARIN. Right? So when you create route objects there, it gets mirrored to RADB. So don't just directly point to RADB, even if you point it, be specific with the source, use an authoritative source, right? And then start creating ROAs. Start creating ROAs of your prefixes. And if possible, start filtering using your ROAs, right? Or the least you can do is join industry initiatives like MANRS, mutually agreed norms for routing security. And Aftab will follow. Aftab will share more details about this. So quick news, AT&T since February dropping invalids. CCOM and Work Online in Africa, they're also dropping invalids since April. And last week I was in Myanmar, and Myanmar Internet Exchange is dropping invalids. So, and I was told that BKNIX also tags invalids. So there are people in the industry who are already doing it. So thank you so much. I was reminded that, right on time, Doc. Thank you.
I'll just use your one. Okay, thank you very much, Tashi. Any questions for Tashi at all? We could use Paul's example and nominate people to ask questions. Now everybody sort of looks down at the laptops. No questions at all? Hello? Thank you very much, Tashi.
Thank you.
Thank you. So next up we have Aftab from the Internet Society. Aftab is going to talk about MANRS. Good manners, bad manners? Some kind of manners. Anyway, All yours.
Thank you. Thank you, Philip, and thank you, Tashi, for a quick overview so that I don't have to go into the details. We've been doing it for quite some time, so we tag along quite well. So MANRS. Let's talk about a little background and see why we are here and all this initiative, what it's trying to do. Better routing security through the concerted action. It's a mouthful of things. Let's say what exactly these are. As Tashi explained, BGP is unsecure. It doesn't have that security capabilities it should have. As Dr. Paul was initially explaining during his session, it was supposed to be the trusted networks connected to each other. Well, 64,000 networks right now. I hope you can trust all of them. So the problem is, try to put it in this figure. What's missing? Well, right now, nothing is missing. We have tools to fix the stuff. We have data to show you the problem is there. You have good incentives not to do something absolutely wrong. The only thing missing is your action. Nothing else. The incentive, well, what's the incentive? Tashi gave you a good example. You don't want your company's or your organization name on top of BBC or CNN. He gave you the example of PTCL. It happened in 2008. 11 years later, we are still talking about it. It's not gonna go away. So you make sure that that's a good enough incentive for you that you don't want to be on top of any headline. You may move away, but that headline will never go away. So just do the right thing. It's a good enough incentive. So that's what mutually agreed norms for the routing security is all about. It started a couple of years ago as a community-driven initiative, which ISOC is supporting. We have a backing of the community who decided that, well, we have to do something together because there are some missing pieces, and what can bridge this gap is the community initiative. And that's how it all started. It builds a visible community of security-minded operators. And what we are saying, very small little steps, just to bring everybody on the baseline of the security. That's it, nothing more than that. What you do, filtering, anti-spoofing, both things which anti-spoofing, which Dr. Paul initially explained in the morning session, filtering, which Tashi explained in the previous session. And the other two things are coordination and global validation. The global validation part is the IRR database or the RPKI. Coordination part, just making sure that all the information is up to date. If there is a problem, well, on the domain side of the WHOIS, things are really, really bad, but on the IP side of the WHOIS, I wouldn't call it's not that bad, but it's okay. So, but it's still we can fix it. It's not like millions of domains versus only 3 registries who are trying to do a very good job to make sure the data is up to date. So make sure that the data is up to date, that if there is a problem, at least I can pick up the phone and give that organization a call or send an email that there is a problem, can you fix it? Simple 4 rules, that for the network operators. Then we said, okay, fine, IXPs are here. They have different requirements, and they were quite interested to join the initiative as well. So some of the IXPs, again, combined their efforts and say, well, let's change few rules for IXPs and create another program for the IXPs. And because of that, DE-CIX, Arnold just left the room, and DE-CIX was the founding member of the MANRS initiative for the IXPs. BKNIX is the member of the IXP program. So we are also working for the content development for the CDN side. Hopefully that will be complete soon by the end of this year. So now giving you some statistics, all about statistics, what's happening on the internet right now, last few months and last few years. Last year, 2018, we got the statistics around 12,600 incidents, BGP incidents, but that incident includes an outages. So let's not consider the outage as a problem. It could be because of a fiber cut, it could be because of you turned off your router for some reason, I don't know. Routing incidents. There were 4,739 routing incidents, 40% routing incidents. 2,737 autonomous systems were victims of at least one routing incident. 2,737 organizations were victims of such kind of incidents. 1,294 networks were responsible for 4,000, more than almost 5,000 routing incidents. But if you look at the statistics, so we started collecting data from 2017, and then if you look at the 2018, it shows that the incidents are going down. Well, it's a good sign. Well, not technically right. Number of incidents are going down, but the intensity of every incident is going up. Now they are very well coordinated. The bad guys are learning their lessons and doing things very smartly. So even if you look at the numbers are going down, but more and more incidents are happening, which are hampering your day-to-day network operations. 2 years in review. Let me quickly show this one. So I got the data from the Asia Pacific region only. These are the 10 most. I got the top 10 only. Potential victims from 2017 to 2018: Bangladesh, India, China, Hong Kong, Indonesia, Australia, Philippines, Korea, Japan, and Malaysia. Things are going up and down. 2017, some were less affected. In 2018, some were more affected. Culprits, well, that's the possible culprits, I would say. Probably it could be mistakes or something, but possible culprits. They were not supposed to make those mistakes, but they did for any reason. Again, the list is, top 10 list is there. Luckily, Thailand is not in both lists. Good for you. Can we track this data? So that was the biggest question when we started the initiative. So late last year, we said, okay, fine, we should start tracking this data and create a meaningful interface where people can see what's happening on all the platforms. So MANRS created an observatory. So right now it's in the beta phase and only available for the members, but hopefully we'll be able to make it public later this year, where people can see how the routing incidents are happening, where they are happening, and if there is a trend going down, going up, and how to improve further. So it is for the month of April. The data is related to the APNIC region. So APNIC region is the Pacific and the Asia up to Afghanistan. Total 433 incident. It is just for the month of April. That includes BGP hijacks, possible BGP hijacks, and BGP leaks. If you look at this information, you will see that in well, that pointer is not very good. That the RPKI adoption rate in the Asia Pacific region is very low, mostly unknown. It's getting better. I'll show you in the next slide. It's getting better, but the adoption rate is very slow. So this data is related to Thailand only. Around 363 AS originating from Thailand. Filtering is good enough, 99.44. I'll explain how this works. And anti-spoofing is not good enough. So we get the information from Kaida's spoofer project. The reason the number is low here, it doesn't mean that you are not filtering. It means that we don't have enough data to put here. So if you are working for a network operating ISP and part of the network operations team, If you can download a small software from the CAIDA, CAIDA, their spoofer project is very well known. Just download it and run it a couple of times and see how the results are. It gives us, so we get the feed from them automatically, so we'll put it here and it will show you clearer results. Right, so this is for Thailand. In April, there were 14 incidents. Possible culprits, 6. Routing completeness is good. The IRR database is very well updated in Thailand, and this is good. The RPKI adoption is good. I was looking at the data. Some of the organizations, they have 100% ROAs created. Some have 50%, 60%. But again, there's a long list of organizations with not a single ROA, but they don't own a lot of resources. They don't have a lot of resources. That's why the numbers are showing they're good. But still, a big chunk is unknown. So this is the list of all those which we are saying possible culprits. If your organization is in this list, please talk to me, Tashi, or Dr. Philip, and we'll explain it to you that why you are here and how it can be fixed. It could be because of a mistake. Absolutely, there is nothing wrong with that. Well, absolutely, there is something wrong with that. As Tashi said, if you are establishing a BGP pair, shut it down first, because there are it's BGP is very much it allows everything, right? Most of the BGP implementation were designed like that. But if you look at the so again, let me complete this one and then I'll explain a few things. This is the data from September 2018 till April 2019. Since we started collecting data since September 2018. In that way, you can see the incidents are going down and then all of a sudden it pop up again and then go down. So the trend is good, but quite unfortunate that culprits still is in that limit of 10, 12. They are not the same offenders. The names are changing, hopefully. I can get this data. I didn't want to put that in here right now. But if you look at the RPKI, interestingly, somebody was doing some testing and all of a sudden there were so many invalids earlier this year. And luckily, good thing is they fixed it. So the invalids are gone now. So only unknown and valids are left. So it's a good idea that you're trying to do something with the RPKI. If you're not clear with it, please come and talk to the people who are doing this thing on day-to-day basis, mostly APNIC, NSRC. We are quite closely working with the partners because we always work with the partners. So we can help you in that one. We are not asking you to do the route origin validation right now. At least start with the ROAs. From Thailand, we have only one member. That's quite unfortunate. That's United Information Highway. So they are part of the Network Operators Program. But we have another program, as I said, the IXP program. And luckily, the platform I'm standing right now, BKNIX Peering Forum, BKNIX is our partner, and they are part of this initiative. So why join MANRS? Probably you are implementing all these things. You are making sure that you are implementing all the routing filters, BGP filters. You are not allowing any spoofed addresses. You are doing source address validation. You are implementing BCP38. Your IRR entries are absolutely bang on target. Your whois updates are very well there. And you have created all the ROAs. If you have done all this thing, why can't you just join us and show to the region, show within your country and to the world, to be honest, that we are quite worried about the routing security, and that's why we are here. And share your experience with all the other people in the room. So MANRS is taking off. as Tashi says, it's a hot topic now. People are looking after their updates, what they are announcing and what they are receiving. They are more concerned about it. So of course, they would like to join initiatives like that, where community is coming together and discussing all these things. So it's going up. We had an exponential growth. We started quite slow in the beginning. Of course, it took some time to develop it as a proper community-driven initiative. Any community-driven initiative requires some time, but now it's just going on its own. So almost every day we receive up to 5 to 10 applications to join the initiative, and the community is reviewing all of them to make sure that everything is up to date. That's it from my side, but I would like to say one more thing. If you look at the last 10, 15 RFCs which came out of IETF, they are all trying to address the default behavior of BGP. They are all trying to address it. In last 5-6 months, me and Tashi were in Myanmar conducting a workshop, and we looked at it and said like, oh wow, around 5 RFCs are trying to change the default behavior of the BGP. Yes, the protocol is trying to fix itself through the engineer support, but by the time it will be fixed completely, it will be too late. So we have to do something together, right? And we saw the problem with the AS path validation. It's not gonna work. So the BGPsec, how much we like it, well, it's not gonna work because there are so many problems. There are so many limitations in it. I would call it a problem. And that's why the only thing which can work is trusting each other. That's how it was created. The BGP was created in that manner. Well, you can trust each other, but just follow the guidelines and the rules. So it is easier for both of you, both your peers, to trust each other. So that's all from my side. If you have any question, then please. Oh.
Thank you, Aftab. Any questions for Aftab? Aftab, do you want to nominate somebody to ask questions?
Well, oh, we have a question.
We have a question.
Yes.
Great.
Thank you so much for presentation. Actually, I'm not a big fan of security. I'm working on the connection, but maybe my question is quite stupid. So my question is because not right now we panic, like we have like a new security and so on, right? So you should be aware. So my question is, if I'm a network operator, should I need to be panic of that if I'm not applying the new ROAs or MANRS, and then no one can talk to me? On the other hand, if I'm not doing that, what should be the penalties of the network, of the internet?
So the answer is simple. Thank you for asking this one. So the answer is simple. Should you be panicked for not locking your door, house door? Yes. So apply the same rule to your network. You have to make sure, I mean, there will be some issues, right? There will be some issues, but you have to make sure that you take all the necessary steps. And then say, okay, fine, now I'm secure. It doesn't mean you're 100% secure, you're 99.9% secure, of course, but don't make yourself 10% secure, right? Take the necessary steps. There's a very good reason why these are called BCPs, best common practices, and BCOP are the best common operating processes. The reason is this: people have agreed, well, if you want to run your network, you must implement these things. And then you can say, I am following the industry best practices. Yes, and it's not like they are changing all the time. It's like the basis remains the same. The BCP 38 came out almost, I believe, 20 years ago, or probably more than that. It hasn't changed. The source address validation hasn't changed. So the way you implement it, you may have changed, yes. The implementation may have changed, but the crux of that BCP 38 hasn't changed at all. So it's like filter what you are announcing, filter what you are receiving. Validating, providing us data, a certified data to the world that I am the right owner of these resources. Basics. If you do the basics right, well, you don't have to panic much. So I hope that answers the question.
Okay, thank you very much.
Thank you.
Any other questions? Am I allowed to ask a question?
You are.
So for people who are signing up to MANRS, is anybody checking that the folks who have signed up are actually doing what they've signed up to do?
Yes, so that is part of the observatory. So it is giving us report on a daily basis for the existing members. So we are looking at them and saying, well, okay, fine, everything is in order. The moment something is not order, it generates a notification to the member. Again, it's in the beta phase, so we are testing with a handful of members to make sure that everything is in order. But that's the whole process, to make sure that it's not like, okay, fine, you are in and do whatever you want. It doesn't work like that. It's not going to scale, and it will look bad. So the thing is, our main focus is to make sure that the existing members are doing exactly what they promised to do. So yes, it is a bit, we have 24 to 48 hours of delay in terms of calculating it. We are trying to make it as real time as possible. Our reliance is on third-party data. So the delay is from the data, not from us. So we are trying to generate our own data, but it's going to take some time. So there are some steps, but we will be there soon. We will be there soon. Yes.
No, I was just wondering, because I mean, it's a general question from the community. Certainly when I'm talking about MANRS,
Yes.
it's like, ooh, can I sign up for that? Because people sign up for things
Yes.
to look good,
Yes.
and then they fall asleep and just ignore what they've signed up for.
Yes.
So it's good to see if there's actually checking going on, and somebody or something is saying, hey, you signed up for this, but come on, you're not doing it.
So we take more action on members in action rather than anybody else, right? So if you are part of a network operator in Thailand, I would request you to join or discuss if you would like to join.
Okay, we still have a little bit of time for your slot. That's why I'm asking questions.
Okay.
Tashi.
And leaning on your question heavily, Aftab, would it be correct to assume that as the community joins this initiatives, folks who are not doing it would be isolated to a smaller and a smaller and a smaller portion, right? And folks who are doing good would be the bigger part of the internet. Those who are not doing would be the smaller part of the internet, and you eventually lose out, because you were talking about incentive, right? So would that be?
So it's it's just an incentive of not buying Bitcoin, right? So everybody was buying it. Say, oh, well, I should buy it as well. Well, I can assure you, it's not a Bitcoin FUD. So it's a real community trying to help each other. And right now we are in that phase where everybody is trying to help each other. So there were a few incidents where people posted on very well-known mailing list on Nanog. And all of a sudden, from that mailing list, somebody picked it up and say, I can see one of the peer is known to me, so let me give them a call. So all of a sudden, that, even though it was not from one of our member, but all of a sudden the discussion came inside the MANRS member mailing list. I said, let's call them and fix that issue. They are trying to hijack a prefix, and it was fixed so quickly. So it's just like the like-minded people who are concerned about the security. And then more people join in, and Tashi said, well, who are not willing to, for a very good reason, well, actually the bad reason, they don't want to join, they will be left out, and there will be very few. As you saw that there are not many culprits, 64,000 ASNs, 1,200 who probably made mistakes or did it intentionally. We don't know. It could have been a mistake, but only 1,200 of them. So it's the good versus bad it's clear, but bad is still really very bad. We need to isolate them further. Thank you, Tashi, for the pointer.
Can I just put one more in? We've still got, I'm not trying to fill time, but I think, well, this one's kind of interesting as well, because it's been discussed on quite a few operations lists. I just don't know how many people here in the local community are completely aware. There's some network operators now who are dropping invalids. I mean, it wasn't mentioned explicitly as that, but do you have any observations? I should have asked you as well about it, Tashi, but I mean, do you have observations about that? And any warnings for operators here about that?
So luckily, so 3 announced that late last year. They said they're going to start doing it from 1st April. The date wasn't a very good date, so everybody said, well, they're just joking. But so they said, okay, fine, we will do it from 3rd April. So it's very serious now. So they actually did it, and it was a discussion internally and say, well, what's going to happen? And from their perspective, they shared it on multiple mailing lists. Nothing happened. From their side, operationally, there was no impact. But if you are announcing a prefix which has an invalid ROA, the impact should be on you. These are really very big ISPs, probably tier 2 or tier 1. CCOM, I can say they are very big. If you are unable to reach CCOM, it's bad for you, not for them. So make sure, I mean, I personally don't like unknown right now, the unknown ROAs, but I absolutely hate the invalids. So, I mean, this is a very famous code. You have really one job to do, right, while you're managing a network operations, to look after your resources. IP is your resource. You are the custodian of that resource, and you have to look after that one. And that custodianship tells you to create ROAs. Well, you are lazy, you haven't created one. Okay, that's bad. But you created a wrong one, that's ugly. So you need to understand that. It's under your custodianship, you have to look after it. So if it is invalid, very soon, you won't be able to reach a lot of places. And then you will try to troubleshoot it and you won't be able to figure it out that what's happening. Why I can't reach that ISP or that ASN? Because that ASN has a policy. And the policy is very strict. So, and the thing is, it's going in that direction, whether you like it or not. So Google, Amazon, Cloudflare, Martin just left. I mean, every time I try to pinpoint somebody, he leaves the room. I don't know why. So Cloudflare, Amazon, Google, they all created their ROAs, right? And soon, I mean, it's too early for them because they have big network. Soon they will be at this position where they say, well, we're gonna discard the invalids. IXPs are doing it already. DE-CIX, M6, they just discard it. You drop the invalids, right? So if people are doing it, going into this direction, and you have invalids with you, it's going to be really very bad. So why not just create the ROAs and look after them? Just like your routers, just like your prefix filters, just like your other network equipment. It is part of your configuration, just manage it similarly. Yes, it is important. And Dr. Philip has been teaching this for many, many years. Hygiene of BGP. It hasn't changed. Few new tools have been added, but the hygiene hasn't changed. So let's do something.
And you're also saying that none of my workshops have made any difference at all, so I've been wasting my time.
Well, I wouldn't say that. Well, I was part of your work. I was the attendee of your workshop in 2006. So something has worked. So Tashi must have attended a few, and Nan has been part of it. He helped BKNIX join MANRS. So it's working. It's not like not, but I think we all need to do more. It's just not from one person. That's why we said it works because of the community. And you being part of the community can help us further and advance Dr. Philip's message of hygiene, of BGP hygiene.
Okay,
right.
So on that light-hearted note, thanks very much, Aftab. Do we have any final questions? Sorry, I'm hiding behind the screen here.
Oh my God, okay.
Famously, when we add security, we create new ways for things that used to be benign to become visible failures. For example, DNSSEC, NASA, and Comcast as a tuple that will live in infamy. Has there been a case where discarding invalids has created an outage where there would not otherwise have been one because somebody screwed up their key management rather than because that there was an actual sort of impersonation attempt?
Nothing I can think of right now. There were a few smaller incidents, especially with shared by Mark from the CCOM. They said, well, one of our customer was, they had invalid ROAs, but then we picked up the phone and say, well, come on, hurry up, fix it. And they fixed it. So, because they said we took 3 months and we checked each of our paying customer because we knew that it's going to create a business problem, and business always wins in terms of technology. So they checked all their paying customer and made sure that they are not impacted. And he said, we haven't seen any drop in traffic, a significant drop in traffic. So we cannot say that it has impacted the world. Yes, probably, but it's not been highlighted in a way that we can say, well, there is a problem. I understand probably in few months when more and more people start deploying ROV validation, he will say, why my traffic? And the thing is, the biggest problem with that is you cannot troubleshoot it through normal ways. Traceroute will just show you, or any other way, it will show you that the traffic is just dying over there. Why? No idea. Then you contact that AS. And that AS will just go into their support ticket and they say, well, fine, we'll respond to you whenever we have time. And then it is a black hole somewhere. It will take some time to figure out how it is working. So, but yes, right now, I'm not aware of any such incident which has created a big problem. But those who have implemented the validation, they were very sure that they update their customers that, well, we are going to do this, make sure that you are aware of that. So yeah, good point. Let me look into this one. Try to follow with the invalids who are invalids and if their traffic is dropping somewhere. Or I'll create my own invalid and see where my traffic is going. That's a good point.
All right. Okay. That's been a good discussion. So thank you for the questions and responses and so forth. So thanks very much, Aftab.
Thank you.
Thank you. So I think the bad information, good information brings us very nicely on to the next presentation. Arnold is going to talk about the PeeringDB. And while he's coming up on stage, just again, reminder, we have peering personals at the end of this session, this presentation, and again this afternoon. So Nan is waiting for, we've got quite a few submitted already, but put some more in, and hopefully Arnold will give you a bit more confidence on how you might want to do that. Thanks, Arnold.
Whoops. Yeah. Good morning. So may I have my presentation, please? So we already have heard in the keynote about directory service called DNS from Paul. We have also heard from Tashi as well as from Aftab that we have to take care of our resources. And basically, this is also what PeeringDB is about. So it's not about only peering, but it's about, nowadays, it's about interconnection. So when so it's not working? Okay. So what is PeeringDB basically? PeeringDB is also a directory, it's a database, and it's a database which basically about 3 resources. It's first of all, it's about the autonomous system numbers, or how we sometimes also say it's about networks. The second component is also, it's about collocation, or how we say facilities. And last but not least is about Internet exchange point. And why should you register your resources at PeeringDB? Simply because if you are an autonomous system number, if you are a network, you want to interconnect with someone else, and you want to make it easy for those that they find your information. And what information do you register at PeeringDB? You say what type of network you are, what your peering policy is, at what collocation you may be found, at what internet exchange you are connected. And it's the same for the collocation as well as for the internet exchange point. You as a collocation, as a facility operator, you want to let the outside world know which networks are in your facilities. And for an exchange point, it's just the same. So to register at PeeringDB, it's a good idea, because there then is a single place where everyone is able to find resources. And even what we know nowadays is everything is about automation, and PeeringDB also provides an API to the resource, and a lot of networks also request that you have a PeeringDB record if you want to peer with them. So basically, this is already what I told about it. A PeeringDB record is required by many networks to peer. Why that? Bigger networks, they have not only one peering relationship, BGP sessions, they have to take care of hundreds of thousands, but a couple of them. So Matt, if I would ask you how many BGP sessions do you have to take care of, how many are that, roughly? 10 of thousands. So, and if you would have to do it by hand, you probably would need 10 of 1,000 people as well. So he has to automate. And he only can automate if he has a resource where he can take the information from. So this is the graphical user interface. As I said, PeeringDB has both a graphical user interface, which is for the users, where you can easily look up the informations. For example, what I have here, this is the organization, it's the ARNS, it's the Education and Research Networks in Slovenia. You find here information about the organization itself. And then what you see is it runs facilities, it has networks, ASN 2107, and then it also runs the Internet Exchange Point, the Slovenian Internet Exchange. This is a route server, ASN, and then it also runs, of course, the Internet Exchange itself. This is what you're seeing in the graphical user interface. And what PeeringDB also does is, as you can see here, there are URLs. If you click on that, then you would come to the location, to the facility, where it shows more information about the facilities. It would show the address, it would show the list of networks which are in the facilities, and so on and so on. So what we also have is an API. And as I said, nowadays, it's even more important if you can automate everything. So PeeringDB, every information which is visible via the graphical user interface is also available via the API. And you can easily, you can do everything. You can read, create, update, and delete record. And the API is really, it's lean and it's really powerful. And what it has, of course, it's not as nice as the graphical user interface, because we have to put it up. You find information about the organizations, the net, the I-access facilities, and point of contacts. And then you have derived types, for example, that you see the IX fact that, for example, this is the facilities where an exchange point is. The same as IX LAN, it's more about the LAN information, and so on and so on. So this is a quick example how to query the API. And as you can see, for a non-technical person, it might look a little bit weird, but it's easy for, especially if you want to digest it into another programs, to see the information is well structured because it's in JSON. So what I also have done is to look into PeeringDB, what is stored in PeeringDB about Thailand. So what I found is that in Thailand we have 7 internet exchange points. There are 15 facilities registered. And then what did I do? I looked into the networks at the internet exchange point, and I found out that I see 43 networks in PeeringDB which are at these 7 exchange points. The same is 41 networks which are registered in facilities which are in Thailand. Next is to do a total of that. Networks are both registered at IXs and at facilities. That means this number is definitely not larger as the sum of these both. If it would be equal, then it would mean that none of the networks at an IX is at the facility and vice versa. The last figure what I have is, then I looked at the RIRs at APNIC, RIPE, LACNIC, and so on, and looked up. They also provide information where they delegated AS2. And then I found out that a total of 562 ASN are somewhere registered in Thailand. That means there are still roughly 500, perhaps, which do not show up somewhere at an internet exchange point or at a facility. That might be. These are more enterprises which are not yet used to register their information somewhere else. So what do the rest of the figures mean? So what I also did is to look into where are these networks coming from, which we see at an IX. So, and it's the same as for facilities, and this is the list of countries where I found out. So what we see is most of the networks which are connected to an internet exchange point in Thailand, they come from Thailand. It's the same for the networks at the facilities. And then we saw only a few which come from the surrounding countries and a few which come from Europe or even from the US. So in the next slide, what I did is to compare Thailand to the neighboring countries in terms of IXs, facilities, and the same what we have done before. We already have been in these numbers, and if you see, for example, at Cambodia, we have 3 IXs. At Laos, we have not yet no IX, no facilities, and then it's, of course, 0 networks and facilities. But we have a total of 3 networks in PeeringDB, and we have a total of 30 networks in the RIR. So at least there could be an IX, they should probably show up in a facility. Same is for Myanmar, there is 1 IX, we found 2 facilities, a couple of networks. Basically, it looks like all of them are connected to an IX, and not that much at a facility. A total of 13, that means this one network most likely is not connected to the IX. and so on and so on. And what we see also is 26 networks in PeeringDB and a total of 81, which is, I think, a good relationship with 1 to 3. The same 1 to 4 over here for Malaysia, and for Thailand, this is 1 to 9, roughly. So that much to figures. But come back to PeeringDB. What is PeeringDB? PeeringDB is around since 15 years meanwhile. And 5 years back, we found out that PeeringDB is really critical infrastructure because people are relying on it. Until then, there were just a couple of volunteers which take care of that. And 5 years ago, we thought it's necessary to have an organization behind it. So what we did is we founded an association which is based in the US. And it's really easy to become a member of this association. You simply have to have a PeeringDB record, and then you have to subscribe to our governance mailing list. And then you are a member. And if you are a member, you are eligible for voting and to be voted on the board. So currently we have roughly 350 subscribers to this member list. It could be more, but I guess that's okay. And of course, this association and the board takes care of the strategic direction, and it takes care that there is enough money to run the association. But the day-to-day work is basically done by so-called committees, and we have 4 committees. The first one is our, I would say, our support department, which we call admin committee. This really takes care of all the user requests. So whenever you want to add a network, a collocation, or an internet exchange point, this automatically will open a ticket at our admin department via our ticketing system. So and what the admin do is to look into the request. Is it really the owner who is requesting this network to be added to PeeringDB? Is it a legit request? And especially what it's harder to decide for networks, we simply look up who is our RDIP to validate the information. But what it's harder to look at and to scrutinize is whether a facility exists or not. And so what we do is, if someone wants to add a collocation, he at least has to provide a URL. And if we serve the URL somewhere, we have to find information about the collocation service. And if not, then we will turn down the request, because we only would have validated information in PeeringDB. If someone says he is offering a collocation service, then he also should really offer the collocation service. The same is for IXs. So if there is an IX, what we require is that on your website, you clearly say, we are offering IXP services, and this is our rule to connect to our IXP, and this is at least our list of members, and at least have to be 3 members. So this is what the admin committee is doing. The next committee is the operations committee. PeeringDB runs the website. We have the web server. The database has to be somewhere, and there has to be people who look after these services. This is what the ops committee is doing. The next one is what we call outreach committee. This is best described as our marketing department. We want to go out to promote what PeeringDB is. We want to give presentations like I do now over here. What we also did, for example, is at the last APNIC, we had our first ever tutorial because we think it's not enough to just hold presentation like this, but also to give tutorials, workshops, more in depth to explain what you can do with PeeringDB, how it is structured, and especially also to cover topics like the API, how to work with the API, how to make use of it. Last but not least, there is a product committee, which is what the name says is it manages the roadmaps and the development priorities, and it asks for input. So what we are using we are using GitHub for both collecting, if you run into a bug, then report it via GitHub, or if you want to have a feature implemented in PeeringDB, also open an issue in GitHub, and then the product committee will look into that. Because we found out that, especially developing a roadmap, having new features is really crucial for PeeringDB, for the users. What we did is we hired our first ever employee, and this is our product manager. This is Felice, and Felice is, I guess, well known to the community. She started working for PeeringDB as a product manager 1st of April, and her responsibilities are to create a roadmap, and then to make this roadmap known to our marketing department, to the outreach committee, who will tell the outside world. And also, currently, if you look at our GitHub repository, you see something like 150 issues which are open, from minor ones to major ones, and what she also has to do is to shepherd the discussion and bring it to a final conclusion and decision. So some of the issues are complicated, talked about, should we have this feature? If not, what are the implications? And if we decide to have it, when will we have it? And so on and so on. And if we decided to do something, then she also has to take care that it is well implemented. Currently, we have one organization, one company, which takes care of implementation of PeeringDB features. This is 20C, which also wrote the new implementation of PeeringDB, but we are also looking for other companies to do development work. Then also, of course, to maintain the release schedules. So we aim of having new releases, that mean incorporated bug fixes and new features roughly every 1 to 2 months to keep PeeringDB up to date, and especially also to have bug fixes. So does PeeringDB cost money? Of course, there are costs involved. There are costs involved to do the development work. There are costs involved to run the infrastructure. But to register your resources, to register your network, your facility, or your IXP does not cost any money. And the reason for that is really simple. There are tens of thousands of networks around. There are a lot of facilities around. There are not so many IXPs around that, but it would be nearly impossible, at least for PeeringDB, to send an invoice to every user. So what do we do instead is we try to cover or recover the cost by sponsorships. And as I pointed out, big networks, they really gain from having PeeringDB, because then they can offload work to PeeringDB. They simply say, I'm willing to peer with you, but when you want to peer with me, you have to be a proper PeeringDB record. Then they can pull the information from PeeringDB and save a lot of time of work. And for that, they are willing also to sponsor. And of course, it's not only to get benefit from it, but a lot of companies simply say this is a good thing, this is something we need, this is an infrastructural thing, and we are willing to donate. We have several sponsorship levels, starting as low as $200 per month, and the highest one is 25,000. So this is our list of sponsors. Thank you to them. And now I would like to talk about 3 or 4 items which we were working on. First of this is rebranding. So when we, as said, PeeringDB is around 15 years. We restarted roughly 3 years ago with a new software, with a new interface. But at that time, we did not really look into how PeeringDB looked like. We did not even have a logo. It was more about functionality and not that much about look and feel. But we felt now it's time to also have a nice look and feel, and therefore we did a complete rebranding. Especially, we have a new logo, and this logo with 3 items that should reflect the 3 attributes: database, interconnection, and I guess what I also forget to mention is most of the information is user maintained. If, for example, Matt is adding or wants to have something changed for Facebook, he has to log in, he has to keep it up to date. Most probably, he will not use the graphical user interface, but has something behind which drives the API. What the admin committee does is it only corrects information which obviously is wrong. So what we do not want to have is wrong information in PeeringDB. If we see something like an IP address, this cannot be an IP address, or this does not match to be within the IXP LAN, we will then correct them. What we also do is we look, for example, into facilities. We tried to add right information. If street address is missing, we are looking after that, and so on. What we also did last year is, as mentioned, the PeeringDB software was written from ground up 3 years ago, 4 years ago. We made it open source. We made it open source for 2 reasons. One reason is that you are able to look into it, to check it, to validate it. There's nothing wrong with it. But the most important, what we would like you to do is, if you want to add a feature, or if you find a bug, you should be able also to submit something for PeeringDB. Next is what we did is internationalization support. When the software was written, there were already hooks in it to support internationalization. We started 4 years ago to have PeeringDB only in the English language. Then, the year before last year, we had demand from Brazil, which is a real vivid community over there. There are a lot of ASNs in Brazil. I would say roughly 1/3 of all ASNs in Brazil are registered PeeringDB. And they say it would be nice to also have PeeringDB in Portuguese, respective Brazilian. We said, okay, no problem. Let's try to tackle with that. And we started to have it implemented in Portuguese as well. There are roughly 3,000 to 4,000 strings which has to be translated. That is not too much. And meanwhile, we are so far that we have already a procedure behind it. We are using WebLate, which is supporting translation of software or anything else. And as you can see, these are the languages which we are currently working on. And as of today, all of these languages, at least those which we have enough coverage, should be supported. So if you have a PeeringDB account, just click on your username, and then, for example, you would be able to choose any languages which is supported. Be careful not to choose languages which you do not understand, because then it might be hard to switch it back. I did it, so I had almost to go through every string I found there. So if you want to contribute for translation, it's quite easy. Just open an issue on GitHub, say, I want to help translate it to this language. What we then will do is to check out the strings to Weblate. The only other thing which you have to do is you have to have a PeeringDB account. You will be able to log into Weblate with your PeeringDB account and then just start on translation. It's not that hard to do that. The only hard thing is because sometimes sentences are broken up in one or in two or more pieces, and then you do not know how is the rest of the sentence, and this makes it hard. But whenever a translation happens, what we do is we have better.peeringdb.com, where you always find the next release. You are able to check your translation and then go back to the translate service and to see how you could perhaps translate it better. So as said, this is not yet put in stone, but we do not want to show translations where there is only 5% translated. So as a rule of thumb, we probably will say you have to translate 80%, and then it will be copied into production. So that is from my side. There are more information about PeeringDB, and I'm happy to take remarks, questions, and anything else. Money as well. Thank you.
Right. Thank you very much, Arnold. Are there any questions for Arnold? Any volunteers for a Thai translation? And we've got folks from other countries in the region as well, so if you're feeling a bit bored sometime, I think we've got a Bhutanese volunteer sitting right over there for the 12 autonomous systems in Bhutan. There are 504 autonomous systems here in Thailand. I was just looking in the database, so that's quite a lot that could be added to the PeeringDB, and it's all useful for the peers as well. So encourage you all to do all that. Questions for Arnold? Yeah, Aftab.
Hi. So you mentioned something about the incorrect data. So are you doing actively something as a PeeringDB is doing something actively to check the validity of the data, or whatever numbers added it remains there?
So what we also plan to do is, of course, what I, for example, found out, we have roughly, about 100 ASNs, which were registered to sometimes to someone, but are currently free. What we will do is to run, for example, through all the ASNs to see if they are still registered with some RIR or assigned to someone. What is harder to do is to cross-check is whether it's the same organization it's assigned to. But we are validating this, if this was your question. What is also hard to do is for collocations to see whether they still are in operations or not. There, we are trusting our principle that you as an operator, you as the owner, has to take care of the data. If you do not any longer operate the collocation, then just notify us. We also get information from other users who say, okay, this collocation is not longer in place, this network is not longer in place, this IXP does not longer exist. Then we are checking this data, and then we are updating, for example, the information or removing it. Does that answer your question? Yes.
Just follow up on that question. How do you report incorrect data? Because I haven't seen anything on the interface where you can say this network has uttered the wrong information.
How do we?
How do we report it? I haven't seen anything on the interface where you can click to or to just say, oh, this is a wrong entry, or I have.
So on every, if you visit PeeringDB.com, every footer has support@PeeringDB.com.
Okay.
Just shoot an email to support@PeeringDB.com.
Okay, all right.
So there's not that we have a template to report it, but just report it to our support department. We will be happy to answer it, and typically we are really fast. We will answer your request within 6 hours or so, meanwhile. Yeah. We are committed to do it in 24 hours.
Wow, that's an expectation that's been set for a long time in the future. Arnold said.
Yes.
Okay, any other questions? No? All right. Well, thank you very much, Arnold.
Thank you.
Great presentation, thank you. So before we break off, let's do the peering personals first, then we can do the formalities to close the session. Is that all right? Or do you want the other way around? Do that first. Okay. Okay, so can we have the three presenters back on stage to thank you for your presentations? Arnold, Aftab, Tashi.
So for this session, may I invite Dr. Yan Yong Teng Amnoy to present a gift for the three speakers, as well as Dr. Philip Smith.
All right, thank you all very much. Okay, so before we go for lunch, can I ask Nan back on stage and we just do 5 minutes of peering personals? Yes? Would you like the mic?
So the organization that I named, please come up on the stage. The first one is IPTP network. So please come on the stage.
Okay. Hello, everyone. My name is Kim Lu. I'm from IPTP. Our IS number is 41059. Our traffic volume is over than 1 terabit. Peering policy is restricted. Peering location, 170 location around the world, and we present in many of the internet exchange. like DE-CIX, unsecure net node, COSI any2, links, Moscow Internet Exchange, APNIC, JBNAV, JBIX, BBAX, Kings, and so on. We would be very happy to peer with anyone can meet our peering policy. In case anyone do not meet our peering policy, we would be very happy to open discuss about the reciprocal business and just define the commercial basis relation. Thank you so much.
Next, Facebook. Next, Facebook.
Hey, my name is Matt. I work for a social network. You don't see a lot of information on that slide. That's deliberate. The important thing here is our PeeringDB entry. That has two reasons. A, I'm lazy and don't want to update the slide all the time. But B, more importantly, as Arnold was telling us earlier, basically all our automation is based on PeeringDB. So we will not actually be able to peer with you if you do not have a PeeringDB entry, because I cannot actually set up the session in our system if it cannot pull the data from there. So we definitely encourage you to be on PeeringDB if you want to connect to us. On top of kind of traditional peering, we obviously do supply caches to run inside your network. And that's actually by far the biggest chunk of our traffic being served from that. I mean, if you look at Thailand here, around 90% of our traffic here is actually served locally from caches in Thailand. So if you're interested in any of that, please just contact us. Thank you.
Okay, the next one is Arnold from DE-CIX.
Yeah, it's me again. I'm also working for an internet exchange called DE-CIX, and this is just the information about DE-CIX. We are running internet exchange point in Europe, in US, in Dubai, and in India. And if you want to know more about DE-CIX, there is an advanced search. Just search for DE-CIX and you will find all the internet exchanges over there. If you have specific questions, I'm around today as well as until Friday. Just contact me. Thank you.
Thank you. The last one is come from Akamai and also Peering Asia 3.0.
Hello, my name is Cam Cheung. I'm one of the network architect of Akamai. So we have two major peering AS. One is AS 20940, which is for our content delivery. And we do have a lot of traffic and we connect to a lot of IX that include BKNIX, of course. And so if you want the peering, so we also require peering DB entry because we also have automation with that. And you would want to, and then you could send an email to us. And then we could have an open peering policy to peer with you. Next one. Yeah. And then we have another AS that is more for the DDoS scrambling service that we have. That is with ASV2787. So if you are in the common location that could peer with us, so we're also welcome to peer with us. And then you can also send an email to peering@akamai.com. And then, yeah, and then we do support IPv6 for both networks. So, then next. Yeah. So, other than Akamai, and now I'm wearing a hat for Peering Asia. So, I'm one of the working group committee for Peering Asia. So we are organizing the Peering Asia Peering Forum. So we have the 1.0 and 2.0 before, and then this year we are going to have the 3.0 in KL, Kuala Lumpur in Malaysia. That is in Intercontinental Hotel in 6th and 7th of November. So other than peering with each other. I think if you want to meet other people face to face, this is a good chance that you could come to the event and then do a lot of social networking also. And it's hosted by Malaysia IX and MANRS. So it's something like this kind of forum that you have BKNIX Peering Forum and also have MANRS. So this is two organizations that they co-host the Peering 3.0. And I'm not talking much about Malaysia, but Malaysia is definitely one of the good Central Asian city, and I think it's easier to fly from Bangkok to KL also, like within 2 hours. And this is location in Intercontinental. And there's a lot of social event that during the Peering Asia that you could join. And of course, there's a lot of good food, and then you can stay behind for your own holidays. Yeah, so see you in KL. Thank you.
Okay, thank you very much. So that's all for the Peering Personal one. So we have another session on the afternoon, so you have enough time to send the slide to us. So thank you very much for this session.
Okay, thank you very much. And this concludes our second session. And for lunch, the lunch will be on 7th floor. The restaurant is called Food Exchange. Please we follow the staff. The staff will direct you to the 2nd floor restaurant and enjoy your meal. And maybe we'll meet again at 1:30. Okay, 1:30.